So welcome to Biosim channel. So in this session we'll discuss the Z scheme of light reactions. Photosynthesis is completed in two steps. Number one, light reactions. Number two, dark reactions. So light reactions are light dependent reactions and dark reactions are light independent reactions. And the site of light reactions is granum and the site of dark reaction is stroma. So let us start with the Z scheme of light reaction. Dear students, this PS second is a pigment system complex consisting of several chlorophyll pigments and one molecule of reaction center, and this is PS1 complex, that is pigment system 1 complex. So this PS second complex, in which one molecule of reaction center is there, which is going to absorb 680 nanometer wavelengths of red light, because of which what happens, the chlorophyll pigments get excited and they are going to release the electrons, which are picked up by the electron acceptor molecules, and this primary electron acceptor is going to get the released electrons from the chlorophyll pigments, and these electrons, means a pair of electrons, are transferred to a component, that is electron transport system, which is made of or consisting of three electron carriers, and they are plastoquinone, cytochrome complex and plastocyanine. So these are the electron carriers which are going to form the electron transport system. That means the electrons, or a pair of electrons, are picked up by primary electron acceptor, and these electrons are transferred to plastoquinone, cytochrome complex and plastocyanine. Here what happens, the movement of electrons is downhill type, that means from higher energy level to lower energy level. So whenever the electrons are moving from plastoquinone to cytochrome, at cytochrome what happens, the energy is released, so that energy is utilized in the formation of what, ATP molecule. That means during the transfer of electrons from plastoquinone to cytochrome complex, what happens here, the energy is lost, so that energy is utilized in the formation of ATP molecule, which is nothing but what, energy rich molecule. So after that the electrons are passed on to one more complex, that is PS1 complex. There also pigments are present and one molecule of reaction center is there, which is going to absorb light radiations or light wavelengths of 700 nanometer, and simultaneously the solar radiations are falling on this complex also. The electrons are jump to higher energy level, and those electrons also move on to the electron carriers. That means here ferredoxin is the electron acceptor molecule. So this ferredoxin, the ferredoxin is the electron acceptor, and the electrons which are released from this complex, that is PS1 complex, are accepted by ferredoxin, and these electrons are then utilized in the reduction of water NADP to NADPH2. And one more very important event takes place, that is photolyzer water. So water molecules are going to split up and they are going to release two electrons and two protons. So these electrons are transferred to this complex, because here the electrons are released from this complex to compensate the loss of electrons. Continuously what happens in plants, the water molecules are splitting and the electrons are transferred to this complex, and the protons which are released, so these protons are going to utilized in the reduction of NADP to NADPH2. The electrons from this complex as well as protons from this photolyzer water utilized in the conversion of NADP to NADPH2. So this is how the energy or solar energy is utilized in the synthesis of ATP and NADPH molecules, and which are known as what? Assimilatory powers. So these assimilatory powers are utilized in the dark reactions. So thank you for watching this.